Hello everyone. In this video, we are going to discuss about the basic operations on signals. Okay. Specifically, we are going to see the operations performed on independent variable. We'll be having two types of variables. One is dependent variable and another one is independent variable. In this video, we are going to discuss about the operations performed on independent variable. Okay. What are those basic operations performed on independent variable? Let us see. First one is delaying or advancing. First operation is delaying or advancing. We call it as time shifting. We are going to shift the time depending on delaying or advancing. Second operation that we are going to perform on independent variable is time folding. Okay. Second one that we are going to perform is time folding. And lastly, the third operation that we are going to perform on independent variable is compression or expansion. Compression or expansion, we call it as time scaling. Okay, these are the three basic operations performed on signals, the two independent variables. Okay, first one is delaying or advancing, we call it as time shifting. Second one is time folding, and third one is compression or expansion, we call it as time scaling. Okay, let us discuss in detail about these three operations. Okay, and the very first operation is delaying or advancing, right? Delaying or advancing. As we say, delaying or advancing, we also call it as a time shifting. Remember that. Okay, let us consider a continuous time signal x of t. Okay, now we are going to consider a continuous time signal x of t. Then output y of t is equal to x of t minus t naught. If x of t is an input or a signal, if the output of the signal y of t is equal to x of t minus t naught, then it is known as time shifted version of x of t. Okay, then the output y of t is known as the time shifted version of x of t. Y of t is a time shifted version of x of t, where t naught is the time shifted. T naught is the time shifted. Y of t is the time shifted version of x of t with the time shifting of t naught times. Okay, if t naught is greater than 0, then the waveform is shifted to right side. Okay, if the value of t naught is greater than 0, which means positive values, then the waveform is shifted to right side. Okay, if t naught is less than 0, then the waveform is shifted to left side. Okay, if the value of t naught is -1 -2, then the waveform will be shifted to the left side. Remember here, you should be very clear. If t naught is greater than 0, which means t naught is equal to 1, if t naught is equal to positive value plus 1, then x of t minus t naught will be y of t is equal to x of t minus 1. The value of t naught is plus 1, minus into plus 1 is minus 1. Remember that. If t naught is less than 0, which means if I am going to take t naught is equal to -1, then y of t is equal to x of t. Now the value of t naught is -1. -1 into minus is plus 1. Remember that. If t naught is greater than 0, we'll be having x of t is equal to y of t is equal to x of t minus 1. Then the waveform is shifted to right side. If the value is x of t minus 1, the waveform is shifted to right side. If the value t naught is less than 0, y of t is equal to x of t plus 1, the waveform is shifted to the left side. Okay, hope it is very clear. The same thing will be holds good for the discrete time signal. Remember, this is for continuous time signal. The same thing is holds good for discrete time signal. Only thing is t is replaced by n. T is replaced by n, and t naught is replaced by n naught. T is replaced by n and t naught is replaced by n naught for discrete time signal. Okay, to understand this even more clearly, we are going to take an example, and here is an example. You can see the signal is x of t. It's a continuous time signal, x of t. It is starting at 0. It's a triangular wave, or we can call it as a sawtooth wave. Okay, it is starting at 0, and at t is equal to 1, the amplitude is 2, and at t is equal to 2, the amplitude is 0. It's the original signal x of t. Now, as we said in the previous one, if t naught is greater than 0, we can see t naught is greater than 0, y of t is equal to x of t minus 1, the waveform is shifted to the right side. The waveform will be shifted to right side. Now, here we can see, now we are going to put t is equal to plus 2. Sorry, t naught is equal to plus 2. It will be x of t minus 2. Then the waveform is shifted to the right side. You can see previously it was at 0. It was starting at 0. Now it is shifting for a 2 seconds or a 2 time interval. You can see t is equal to t minus 2. It is shifting 2 times. It has to be started at 0, but it is delaying. The signal is delayed by 2 units. It used to be started at 0, but it has been delayed 2 units because t naught is equal to 2. Actual signal starts at 0. Since the signal is delayed by 2 units, 1, 2, and it is starting at 2. The amplitude remains same. Okay, the amplitude doesn't change. Only thing is delayed by 2 units. Now, if the value is less than 0, now x of t plus 2, which means t is less than 0, the waveform shifted to the left side. Here we can see the waveform is shifted to the left side by 2 units, t plus 2. So it has to be started at 0, but it is advancing, 2 units advanced. Previously it was started at 0, now it has been starting at minus 2 because signal is advanced by t naught is equal to 2. 0, minus 1, 1 unit, minus 2, 2 units. It has been advanced by 2 units. Amplitude remains same. Hope it is understood. If you want to understand more, I'll be releasing the problems on these topics in the next video. We can discuss it there. Okay. And the next topic is next operation that is performed on independent variable is time folding. Next operation that is performed is time folding. Again, let us consider x of t be a continuous time signal. Let x of t be a continuous time signal. Then y of t is equal to x of minus t is called as a time folded version of x of t about the amplitude axis. Okay, and remember, amplitude remains the same. Okay, remember, amplitude remains same. Even in the previous one also, advancing or delaying, amplitude remains same. Here also in time folding, the amplitude remains same. Only thing is the signal is folded with respect to the amplitude axis. Okay, to understand this, we can take an example. And here is an example. The same previous signal x of t. Okay, this is the signal x of t starting at 0 and ending at 2 with an amplitude 2 at time t is equal to 1. Okay, this one we are going to fold it with respect to the amplitude axis. Remember, this is the time axis, whereas y axis is nothing but the amplitude axis. X axis is time axis, y axis is amplitude axis. Now if I am going to fold the signal with respect to amplitude axis, if I am going to fold it, okay, what would be the reflection of this signal? Whatever the signal appears on the negative part of the time scale, if I fold it, that would be the time folded version. And here we can see x of minus t. This is x of t and I am folding it with respect to the amplitude axis. If I fold it just above the amplitude axis, the signal here will appear like this, which means this is similar to that of the one I have written below. Hope you people can imagine the sequence that appear when we fold the line. Hope many of you people have done that paper folding and making the drawing with respect to the paper folding idea. Okay, just remember that if you fold this with respect to amplitude axis and if you rub the sheet, whatever the mirror image that appear on the other side of the axis will be your time folded version. Okay, hope you people are getting the idea behind time folding version. If not, we are going to solve a few more problems on this. This is just an ideology behind the concept. Okay, please do put a message on my comment box if you have any doubts. We'll be connected. Okay, and the last one with respect to the operations is compression bar expansion, which we call it as time scaling, right? Compression or expansion, which we call it as time scaling. Again, for this, let us consider x of t be a continuous time signal. Okay, let x of t be a continuous time signal. Then y of t, the output y of t is equal to x of a times t, where a is an integer. Okay, y of t is equal to x of a times t, where a is an integer. Then the signal is said to be compressed. Okay, and if y of t is equal to x of t by a, remember a is an integer, then the signal is said to be expanded. Okay, if the output is x of a times t, then the signal is compressed, and y of t is equal to x of t by a, then the signal is said to be expanded, where a is an integer. Okay, where a is an integer. To understand this better, let us consider an example where we are having x of t. Okay, x of t starts at -2 and ends at +2 with an amplitude by step. Okay, x of t starts at -2 with an amplitude 1 and it remains 1 till t is equal to -1, and it rises to amplitude 2 till +1, and again at amplitude 1 from 1 to +1 to +2 time. Okay, this is the actual signal x of t. Now as we discussed here, y of t is equal to x of a times t, then the signal is said to be compressed. Okay, now I'm taking a is equal to 2. Let a is equal to 2, x of a times t means 2 times t, then the signal is compressed by 2. Okay, previously it was -2 to +2 and we are dividing it by 2. 2 times t means we will be divided by 2. Okay, -2 by 2 is -1, +2 by 2 is +1, -1 by 2 is -1 by 2, +1 by 2 is +1 by 2, and the signal remains same, amplitude remains same here. Okay, it is just compressed, signal is compressed with the same amplitudes, only time is shifted. Okay, -2 by 2 is -1, -2 divided by this integer value, -2 by 2 is -1, -1 by 2 is -1 by 2, 0 by 2 is 0, +1 by 2 is +1 by 2, +2 divided by 2 is +1. Okay, x of at, as we said, x of at, then the signal is compressed. Okay, this is the compressed version. Similarly, x of t by a, now we are putting a is equal to 2, x of t by 2, then the signal is expanded. As we said, the signal is expanded for x of t by a, then the signal is expanded by a times. Signal will be expanded by a times. X of t by a, which means a is equal to 2, x of t by 2. Okay, -2 into 2 is -4, -1 into 2 is -2, 0 into 2 is 0, 1 into 2 is 2, 2 into 2 is 4. The signal amplitude remains same, only thing is the time has been enlarged or expanded. Okay, this is the compressed version. When we multiply by an integer a, when we divide by an integer a, then the signal is expanded. Hope this is clear for you people. If you have any doubts, please do put a message on my comment box. We'll be connected. If you want few more understanding, please be connected for the next videos. We'll be solving problems on these topics. Okay, time scaling, time folding, and time shifting. Okay, basic operations on signals. We'll be solving some problems in our next videos. Thank you.